Hello everyone. Let's look at general solution using graphical method. There are two methods of finding a general solution. There is a graphical method that I'm going to discuss with you now. There is also a reference angle method. So let's look at the graphical method. So we have three solutions. We have solution for tangent, we have solution for cosine, we also have solution for sine. Let me start with the tangent. So if you have a tan angle x is equal to a, so with tan, a can be any number. A is an element of all real numbers. So the solution for tan, if we are using a graphical method, we only have one solution, which is x is equal to arctan. So remember arctan, you just press shift on your calculator. Arctan of a plus k multiplied by 180, where k is an element of integers. That is the solution for tangent. And then number two, we also have solution for cosine. So cos of an angle, cos x, is equal to a will give you, you just say x is equal to, now when you are doing general solution for cos and you are using a graphical method, so you just put plus or minus first. X is equal to plus or minus a cos of a plus k multiplied by 360, where k is an element of integer. So you just put plus or minus. Last one is the general solution for sine. So for sine, if you have sine x is equal to a, again, a must be a value from -1 to 1. So your x will be x is equal to the first solution. So with sine, there are two solutions. The first solution is arcsine of a plus k multiplied by 360, where k is an element of integers. Or solution number two will be x is equal to 180 minus arcsine of a. So you just subtract the angle that you got above, minus arcsine of a plus k multiplied by 360, where k is an element of integer. Now, these are solutions using graphical method. So you need to know all of them. You need to know the solution for tangent. You need to know the solution for cosine, where you put plus or minus. You also need both solutions for sine. So let me take you through different examples. Okay, let me start with number one here. So number one, find the general solution. We are given 3 sine x minus 2 cos x is equal to 0. So with this one, you can see that number one, we have sine and cos. So now if you have sine and cos, as long as these two angles match, as long as these angles match, you can always take this to tan. How do I take this to tangent? Remember, tan x is the same as sine x over cos x. So I can divide everything by cos x. So if I divide everything by cos x, I'm going to have 3 sine x. Now I am dividing by cos x. Minus 2 cos x, and then you divide by cos x is equal to 0. Now you will then notice that you now have tan x here, and this and that will just divide. Now we are going to have 3 tan x minus 2 is equal to 0. And then we make tan x subjects of the formula. So we are going to have tan x is equal to 2 over 3. Now we can find the solution. So the solution is therefore x is equal to arctan. So shift tan 2 over 3, and then plus k multiplied by 180, where k is an element of integers. And then now this will be what is arctan of 2 over 3? It is 33,69. So you are going to have 33,69 plus k multiplied by 180, where k is an element of integers. So you are done. So with this solution, you will get full marks in the exam or test. So obviously, if you are using reference angle method, another solution that you are going to have is 180 plus 33,69, and then plus k multiplied by 180, where k is an element of integers. But if you are using a graphical method, this solution that we have here is enough. So your solution is x is equal to 33,69 plus k multiplied by 180, where k is an element of integers. And then let's go to example number 2. Example number 2, find the general solution again. If we have 3 cos squared, if we have 3 cos squared as 4 cos x minus 2 is equal to sine squared x. So now with this question, again, we are required to find general solution. You will then notice that everything is expressed in terms of cos x, except this sine squared x. But remember, we can always change sine squared x and write it in terms of cos. So here we have 3 cos 2x plus 4 cos x minus 2 is equal to, now we can change sine squared x because sine squared x is an identity. So it can be written as 1 minus cos squared x. And then we write this in a standard form, ax squared plus bx plus c is equal to 0. So transpose everything, take everything to the left. So we are going to have 4 cos squared x plus 4 cos x minus 2 minus 1, it is minus 3 is equal to 0. So how did I get 4 cos squared x? These two are like terms. So 3 cos squared x plus 1 cos squared x is 4 cos squared x. Now, this is the same as 4 x squared plus 4x minus 3 is equal to 0. We can factorize this. You can even use a quadratic formula if you want to. If you want to use a quadratic formula, your a is equal to 4, b is equal to 4, c is equal to minus 3. But we can always factorize here, 2 brackets. If we factorize, we are going to have 2 cos x, and then here again we have 2 cos x. We have minus 1 and plus 3. But remember, if you are not comfortable with factors, just use a quadratic formula. So then we have 2 cos x minus 1 is equal to 0, or 2 cos x plus 3 is equal to 0. And then we make cos x subject of the formula. So we are going to have cos x is equal to 1 over 2, or cos x is equal to minus 3 over 2. And then now we are doing general solution for cos. So you need to remember that x will be plus or minus. Remember, with cos we said we must always include this plus or minus if we are using a graphical method. We are going to have plus or minus a cos of 1 over 2, and then plus k multiplied by 360, and then our k is an element of integers. Now, this is the same as x. Now, what is a cos of 1 over 2? It will be plus or minus. So a cos of 1 over 2 is the same as 60, and then plus k multiplied by 360, where k is an element of integers. Now, solution for cos x is equal to minus 3 over 2. Remember from our discussion we said for cos and sine, so this value here must be a value from minus 1 to 1. Now, you will realize that negative 3 over 2, it is beyond that domain, because negative 3 over 2 is the same as negative 1,5. So this one already, we know that it has no solution. And then let's look at question number, let's look at number 3. Question number 3. Find the general solution again, but now we are given tan alpha is equal to cos alpha. Now we are required to find the general solution. So here you can see that we have an identity that we can change. Remember, tan alpha can be written as sine alpha over cos alpha. So we are going to have sine alpha over cos alpha is equal to cos alpha. Now, we can multiply everything by cos alpha. So we multiply everything by cos alpha. If we multiply by cos alpha, even this side, if we multiply by cos alpha, this and that will cancel out. And then we are going to remain with sine alpha is equal to cos squared alpha. Now again, if you check here, we have an identity again. We can change this cos squared alpha so that it match this sine alpha, because there is nothing we can do with this sine alpha. So we can write this as sine alpha is equal to 1 minus sine squared alpha. Now again, we can write this in a standard form. I am going to take everything to the left. So if I take everything to the left, I am going to have a positive sine squared alpha plus sine alpha minus 1 is equal to 0. So this is the same as x squared plus x minus 1 is equal to 0. We can use quadratic formula to solve for sine alpha. So if we use the quadratic formula, we are going to have sine alpha is equal to minus our b is 1, so it's gonna be minus 1 plus or minus square root of it is 1 squared minus 4. Our a is 1, and then our c is minus 1, all divided by 2 multiplied by 1. So now press our calculator we are going to have sine alpha is equal to, and then sine alpha is equal to. And then if we press our calculator, we get, if we use negative, we get negative 1,618, and then here we get 0,618. Okay, now this one we can see already we are dealing with sine, and this number is beyond our domain. Remember, we said for sine alpha the minimum must be -1 and the maximum must be 1. So that means this one, we already know that it has no solution. There's no solution for this one. And then here we need to find two solutions. Remember, with sine we have two solutions. So we are going to have alpha is equal to arc sine of 0,618, and then plus k multiplied by 360, where k is an element of integers. And then now this arc sine of 0,618 is the same as 38,17, and then plus k multiplied by 360, where k is an element of integers. This is our first solution for sine. And then another solution, remember, we are dealing with sine, so it's 180 minus. So it's going to be alpha. You are going to say alpha is equal to, and then it's 180 minus 88,17, and then plus k multiplied by 360. K is an element of all integers. So this is equal to, what is 180 minus this? I am getting 141,83, and then plus k multiplied by 360, where k is an element of integers. Let's go to example number 4. Number 4, let's say we are given cos squared x plus 7 sine x cos x plus 2 is equal to 0. Now with this one, you'll notice that here we have 3 terms. But now we cannot factorize these, because if you look at the first term, we have cos squared. But in the middle term, we have the mixture of sine and cos. So that means we need to introduce something that will accommodate this sine and cos. So now you need to remember the identity. 1 is always equal to sine squared x plus cos squared x. Now, we can write this as, this is cos squared x plus 7 sine x multiplied by cos x plus 2. Now, I am going to multiply this 2 by 1. Remember, when you multiply anything by 1, it remains the same. So my 1 will be sine squared x plus cos squared x. I am trying to introduce this sine squared x to accommodate this sine x here. Now, I am going to have cos squared x plus, it is 7 sine x cos x, and then multiply everything by 2. I'm going to have 2 sine squared x plus 2 cos squared x. Now I have the like terms, so I need to add all the like terms. So this one and that one are the same, so I can add them. So I'm going to have 3 cos squared x, and then plus 7 sine x cos x, and then plus 2 sine squared x. Remember, this is all equal to 0. Now we can factorize this. So now this is the same as 3x squared plus 7xy, and then plus 2y squared. So grade 9 factorization. So let's factorize this. So 2 brackets, and then is equal to 0. So fortunate enough, if you check here, we have prime numbers. So it is very easy to factorize when you have prime numbers. 3 is a prime number. 2 is also a prime number. So the factors of 3, it is only 3 and 1. So we have 3 cos x, and then 1 cos x. So which will be cos x. So factors of 2 as well, it is 2 and 1. So the Maclaurin term is 7. So here we are going to have sine x, 1 sine x, and then here we are going to have 2 sine x, and it plus and plus. So it is equal to 0. Now we have a product that is equal to 0. So that simple means 3 cos x plus sine x is equal to 0, or cos x plus 2 sine x is equal to 0. Again, you'll notice that these two angles, they match, and then you have cos and sine. Even these two angles, they match. So you can always take these two tangent. You can divide it throughout by cos x. So if I divide the first one by cos x, here I am dividing by cos x divided by cos x divided by cos x. You are going to have cos x over cos x is 1. So sine x over cos x is tan x. So you are going to have tan x is equal to, you transpose 3, so is equal to negative 3. Or if you divide by cos x throughout here, you divide by cos x, even here, you divide by cos x. Now, you are going to have tan x is equal to, it is going to be negative 1 over 2. Negative 1 over 2. Because this one here will give you 2 tan x, and then this one will give you 1. You transpose 1, it becomes negative 1, and then you divide by 2, so you have tan x is equal to negative 1 over 2. Now, we are going to have x is equal to arctan of negative 3. Remember, with the graphical method, we do not ignore the negative sign. Remember, with the reference angle method, you will always ignore the negative sign. But with this method, graphical method, you do not ignore the sign. So you just say plus k multiplied by 180, where k is an element of integers. So you are going to have x is equal to, now what is arctan of negative 3? So calculator, we are going to get negative 71,5 and then plus k multiplied by 180, where k is an element of integers. And this is your solution. Here is your solution. So sometimes you will want to make this angle positive. So for tan or for tangent, you can just add 180. So for tan, we add 180. If I add 180 here, so your solution will be minus 71, plus 180. It will be 108, comma 43, comma 4, it's comma 44, and then plus k times 180, where k is an element of integers. But this solution in the exam will always give you full marks. And then arctan, so x is equal to arctan of minus 1 over 2. It will be x. Okay, arctan of minus 1 over 2, and then plus k times 180. K is an element of integers. Now, so this will be x is equal to 26, negative 26, comma 5, 7. If you want to make it positive, you can always add 180. And then if you add 180 here, it will give you 153, 443. Yes. So we are done with example 4. Let's go to example 5. Let's see example 5. Number 5. Number 5, we are given 3 sine 2x minus 2 sine x is equal to 0. Now here we have a double angle. You will notice that here now we have a double angle, but this one is not a double angle. So we need to change this double angle. So this is the same as 3 sine, changing the double angle. So it's 3 into, so sine 2x can be written as 2 sine x cos x, and then minus 2 sine x is equal to 0. So this is the same as 3 multiplied by 2 sine x cos x minus 2 sine x. And then you will notice that we have two terms and there is a common factor because 2 sine x appears in both terms. So we have a common factor. We can take it out, factorize. So we have 2 sine x as a common factor. So if we take it out, we are going to remain with 3 cos x minus 1 is equal to 0. And then we have a product that is equal to 0. So that means sine x is equal to 0, or cos x is equal to 1 over 3. So here we have the general solution for sine. We also have the general solution for cos. You need to remember both of them. So let me start with I think cos is the easiest. Let me start with cos. So here you just say x is equal to plus or minus. Remember, when we are dealing with cos or cosine, you always use plus or minus. Plus or minus a cos of 1 over 3, and then plus k multiplied by 360, where k is an element of integers. And then now, what is a cos of 1 over 3? So this is equal to plus or minus. So a cos of 1 over 3, calculator will give us 70,52, and then plus k multiplied by 360. K is an element of integers. And then what is x? Okay, now let's move to general solution for sine. Remember, for sine, there are two solutions. So the first one, you just say x sine of 0. So x is equal to x sine of 0, and then plus k multiplied by 360. K is an element of integers. So now what is x sine of 0? It is 0. So 0 plus k multiplied by 360. K is an element of integers. Or solution number 2, you just say or, and then you just say 180 minus 0. So 180 minus 0 is always 180. So 180 plus k multiplied by 360, where k is an element of integers. Let's go to number 6. So there are 11 questions here. So I'm trying to cover every nature of general solution. So in total, they are 11. Number 6, we have cos 2x plus 2 sine 2x plus 2 is equal to 0. And then now we have a double angle for cos. We also have a double angle for sine. So now we need to change these double angles. I can see that if I have double angle for sine, it will bring that mixture of sine and cos. So now when I choose the double angle for cos, I need to take the one that has both sine and cos. So I will take cos squared x minus sine squared x plus, with sine 2x, I do not have many options. I only have one option because it will be 2 sine x cos x, and then plus 2. So this 2, I can multiply it by 1 to accommodate this sine x and cos x. My 1 will be sine squared x plus cos squared x, because if I multiply anything by 1, it will remain the same. So now this is equal to 0. So I'm going to have cos squared x minus sine squared x, and then plus, this is the same as 4 sine x cos x. If I remove the bracket, it is plus 2 sine squared x plus 2 cos squared x. It is equal to 0. I can now add the like terms. Cos squared x plus another plus 2 cos squared x. It will be 3 cos squared x, and then 2 sine squared x minus sine squared x. It will be sine squared x plus 4 sine x cos x. And then now plus 3 cos squared x is equal to 0. So this is the same as x squared plus 4xy plus 3y squared. So we can factorize it as this is sine x multiplied by sine x, and then plus, and then with cos, it will be 3 cos x multiplied by cos x is equal to 0. And then from here, we can see that sine x plus 3 cos x is equal to 0, or sine x plus cos x is equal to 0. And then now you will notice that we have sine and cos. And even here we have sine and cos. And fortunate enough, if you look at the angles are the same. So we can always take it to tangent. We can divide everything by cos x. So if I divide by cos x, I'm going to have, or let me start by transposing. So this is the same as sine x is equal to minus 3 cos x. So if I divide by cos x on both sides, so this is over cos x, this is also over cos x. Now, I have an identity, so this is the same as tan x is equal to negative 3, or if I transpose here, I will have sine x is equal to negative cos x. So I divide by cos on both sides, cos x, even here I divide by cos x. Now I'm going to have tan x is equal to negative 1. Now general solution for tan, so x is equal to arctan of negative 3 plus k multiplied by 180, where k is an element of all integers. And then what is arctan of negative 3? So arctan of negative 3 is the same as negative 71,57, and then plus k multiplied by 180, where k is an element of integers. So now if you want to make this angle positive, for tan, you can always add 180 in this negative angle. So if you add 180, you will get 104.43, and then plus k multiplied by 180, where k is an element of all integers. And then with this one, we have x is equal to arctan of negative 1, and then plus k multiplied by 360, not 360 but 180. But even 360 also work. You can even use 360 multiplied by 180, where k is an element of integers. And then x is equal to negative 45 plus k times 180, k is all integers. Now, even with this 45, if you want to make it positive, you can always add 110. You can always add 180, and then you will get 135. So you will get 135 plus k multiplied by 360, where k is an element of integers. Let me move to number 7. Number 7, we are given 4 sine squared x minus sine x is equal to the double angle of cos 2x. Now we need to change this double angle, but now we can see already that on the left hand side we have sine and sine. So when we change this double angle, we must choose the one that has sine. So I will change this double angle to, I will have 4 sine squared x minus sine x is equal to 1 minus 2 sine squared x, because cos 2x is the same as 1 minus 2 sine squared x. And then from here, I will write this in a standard form, in the form of ax squared plus bx plus c is equal to 0. So I will take everything to my left. So 4 sine squared x plus 2 sine squared x. So this will give me 6 sine squared x minus sine x, and then minus 1 this will be equal to, this will be equal to 0. Now, I need to factorize this. Remember, if you are not comfortable with factors, this is written in the form of ax squared plus bx plus c. So you can always use quadratic formula. So if we factorize this, okay, 2 brackets, and then we are going to have 3 sine x multiplied by 2 sine x, and then factors of 1 is just 1 and 1. So we have plus and minus. So the signs are different here. Now, this is equal to 0, and then that means sine x, that means 3 sine x plus 1 is equal to 0, or 2 sine x minus 1 is equal to 0. And then we are going to have sine x is equal to minus 1 over 3, or sine x is equal to 1 over 2. And then now we are doing general solution for sine. So we are going to have x is equal to arc sine of 1 over 3. So plus k multiplied by 360. K is an element of all integers. Now, what is arc sine of minus 1 over 3? Please note that with this method that I'm using, the graphical method, I do not ignore the negative sign. Unlike the reference angle method, where you will always ignore the negative sign. So here I'm getting x is equal to minus 19, 47 plus k multiplied by 360, where k is an element of all integers. So now with sine and cos, if I want to make this angle positive, if you want to have positive angles only, you can always add 360. So for sine and cos, you always add 360. And then remember, when we are doing general solution for sine, we have 2 solutions. So you are going to say, or x is equal to, and then 180 minus into minus 19, 47, and then plus k times 360. K is an element of all integers. Now, 180 minus into minus 19, 47, I think it will give us 190. I think it's 199. I think it will be 199, 47, and then plus k multiplied by 360. K represent all the integers, and then we are done with the first part of the general solution, which has 2 solutions. And then now we have another solution here. Sine x is equal to 1 over 2. So here you will say x is equal to, so 1 over 2, what is arc sine of 1 over 2? Arc sine of 1 over 2, okay, let me write it first. 1 over 2 plus k multiplied by 360. K represent all integers. Now this is x is equal to 30 plus k multiplied by 360. K represent all integers. Or x is equal to 180 minus 30. 180 minus 30, it is 150 plus k times 360, where k represent all integers. And then we have 2 solutions again. So this one and that one. And then we are done with number 7. So we are almost done with these solutions. So number 7, we are only left with 4. Now number 8. Number 8, you will notice that we have sine, cos, cos, sine. So x, 15, 15. So now this is a compound angle that is already expanded. So if you have a compound angle that is already expanded, you need to take it back. So taking this one back, you can see it's a mixture of sine and cos. So originally it was sine. So this is the same as sine x minus, it is x minus 15 is equal to negative sine 2x. Now you'll notice that we have sine on both sides. So if we have sine and sine, we can always drop sine and sine, and then we work with angles. Now, but before I even do that, you will notice this one is now negative. So if this one is negative, it can be written as this is sine x minus 15 is equal to, I want to remove this negative. How do I remove it? I will write this as sine into 180 plus 2x. So remember, 180 plus 2x is in the third quadrant. In the third quadrant, sine is negative. So basically, this is the same as negative sine 2x. It is one and the same thing. You can even use 360 minus. You can even use 360 minus 2x. Now, and then from here, we can write this now because we have sine and sine. Both sides, they are both positive now. We can write this as x minus 15 is equal to 180 plus 2x, and then plus k multiplied by 360. K is an element of all integers. Okay, so now, okay, this is your reference angle that we are going to work with going forward. So now we solve for x here. So I take 2x to my left. I am going to have x minus 2x, which will be what? Which will be minus x is equal to, and then 180 plus 15. So 180 plus 15 will give me 195. So it is 195 plus k multiplied by 360. K is an element of all integers. Then divide by negative throughout. So x is equal to minus 195 plus k multiplied by 360, where k is an element of integers. So if you have noticed here, I did not change this plus. So you can always keep that plus. Even if you change it, it matters not. So our solution is x is equal to minus 195 plus k multiplied by 360, where k is an element of integers. Remember, we said with sine, because here we are doing general solution for sine. There are two solutions. So you are going to say or. And then you go back to that step and say x minus 15 is equal to now 180 minus, and then 180 minus, and then you open the bracket, and then 180 plus 2x, and then plus k multiplied by 360, where k is an element of all integers. Now, remove the brackets and solve for x again. So we are going to have x minus 15 is equal to 180 minus 180 minus 2x plus k multiplied by 360, where k is an element of all integers. Now, okay, 180 and 180, and then take 2x to the left. So you are going to have 2x plus 2x. It is 3x is equal to, take 15 to the right. This is 15, and then plus k multiplied by 360, where k is an element of all integers. And then we divide by 3 throughout. So x is equal to 5 plus k multiplied by, I think it's 120, where k is an element of integers. And then we are done. So here are our solutions. So the first one, where is the first one? Here is the first solution. Remember, if you want to make this angle here positive, you can always add 360. This one, fortunate enough, it is already positive. And then we are done with number 8. Let's move to number 9. So we are given cos 60 multiplied by cos into 2x plus 30 is equal to sin x multiplied by cos x. Now, we can see here cos 60 is a special angle. So we can write cos 60 as 1 over 2. So we have 1 over 2 and then cos into 2x plus 30 is equal to sin x multiplied by cos x. Now, if we multiply everything by 2, we are going to have cos into 2x plus 30 is equal to 2 sin x cos x. And then if you check this is a double angle for sine. So it can be written as sine 2x. So we have cos into 2x plus 30 is equal to, and then we take it back. So this is sine double angle, sine 2x. And then we can see that we have cos and sine. So remember, if we have cos and sine, we take it to tan. But now you need to check the angles must be the same. So these two angles are not the same. So we cannot divide by cos on both sides because angles are not the same. But if they are not the same, remember your cofunctions. So we can write this as cos 2x plus 30 is equal to, and then we change these two cos. We can change these two cos by using cofunctions. So it can be written as cos 90 minus 2x. 90 minus 2x is in the first quadrant. In the first quadrant, cos is positive, but because there is 90, it will go back. It will always go back to sine 2x. So sine 2x is the same as cos 90 minus 2x. So now we have cos on both sides. So we can write this as 2x plus 30 is equal to, because this is general solution for cos, we can just put it at plus or minus. So it plus or minus 90 minus 2x, and then plus k multiplied by 360, where k is an element of integers. Now we want to solve for x here. So we will start with positive. So we will have 2x plus 30 is equal to 90 minus 2x plus k multiplied by 360, where k is an element of integers. Take 2x to the left. So I'm going to have 2x plus 2x, which will be 4x, is equal to, take 30 to the right. I'm going to have 90 minus 30, which will be 60. And then plus k multiplied by 360, where k is an element of integers. And then we divide on both sides by 4. So if I divide by 4, I will have x is equal to 60 divided by 4 will be 15 plus k multiplied by 360. K is an element of all integers. So this is my solution number 1. here is my first solution. So solution number 2. And then from this step here, I'm going to use this angle as negative now. So if I use it as negative, I'll say O, and then now I will have 2x plus 30 is equal to negative 90. Negative and negative will be plus 2x, and then plus k times 360, where k is an element of all integers. Now, if I take 2x to my left, I am going to have 2x minus 2x, which will be 0. So you see now x is gone, so there is no x anymore. So that means that the only solution that we have is the first one. So this one will give us no solution. So we only have one solution. So our general solution is x is equal to 15 plus k multiplied by 360, where k is an element of integers. And then we are done with number 9. So let's move to number 10. Number 10, we have square root of sine x minus square root of cos x is equal to 1. So we can always take this to special angles. If I can divide everything by 2, so divided by 2, divided by 2, divided by 2, you will now notice that root 2 over 2 is the same as cos 45. Even root 2 over 2 here is the same as sine 45 or cos 45. But now since we have sine here, so this can be written as sine x, and then root 2 over 2 is cos 45 minus cos x. Root 2 over 2 is the same as sine 45. This is equal to 1 over 2. Now you will notice that we now have a compound angle that is already expanded, so we need to take it back. So we are going to have, because the mixture of sine and cos, so it was originally sine into x minus 45 is equal to 1 over 2. So it was sine x minus 45 is equal to 1 over 2. Now, we are looking for arc sine of 1 over 2. So we are going to have x minus 45 is equal to arc sine of 1 over 2, and then plus k multiplied by 360, where k is an element of all integers. Now, this is x minus 45 is equal to arc sine of 1 over 2 is 30. 30 plus k multiplied by 360. K is all integers. And then we transpose 45, so we will have x is equal to 75 plus k multiplied by 360, where k is an element of all integers. So here is our solution number 1. This is our solution number 1. And then solution number 2, we will say O, and then we go back and say x minus 45 is equal to, remember, for sine, solution number 2 is 180 minus. So it will be 180 minus 30. 180 minus 30 plus k multiplied by 360, where k is an element of all integers. And then now we transpose 45, so we are going to have 180 minus 30 plus 45. So it will be x is equal to 180 minus 30 is 150, and then plus 45, it will be 195. And then plus k multiplied by 360, where k is an element of all integers. This is our solution number. This is our solution number 2. Now, number 11. Number 11, we are given 3 sine 2x. This is a double angle, plus 3 cos x minus 4 sine squared x minus 2 sine x is equal to 0. So let's change this double angle first. Fortunately enough, with sine, we do not have many options. So this is the same as 3 multiplied by, we change the double angle, which will be 2 sine x cos x. And then plus, we have 3 cos x, and then minus 4 sine squared x minus 2 sine x is equal to 0. And then from here, you will notice that we now have 4 terms. So remember, in grade 10, you did grouping in grade 10. So now we can use grouping here and factorize this. So we can group these first 2 terms and then the last 2 as well. So now if we group here, you will notice that among the first 2 terms, there is a common factor, and that common factor is 3 cos x. We have 3 cos x as a common factor, and then if you take it out, you will remain with 2 sine x plus 1. And then take out the common factor again. We can take out negative 2 sine x minus 2 sine x. And then if you take it out, you will remain with 2 sine x plus 1. This is equal to 0. Now, you will notice that we now have 2 terms after we have taken out the common factor. So this is our term number 1. This is our term number 2. Now you will realize again, among these 2 terms, again, there is another common factor. So the common factor now is 2 sine x plus 1. And then here we will remain with 3 cos x minus 2 sine x. This is equal to 0. Now the product is equal to 0. So that means 2 sine x plus 1 is equal to 0, or 3 cos x minus 2 sine x is equal to 0. And then here we are going to have, excuse me, here we are going to have sine x is equal to minus 1 over 2, or here you will notice that we have cos and sine, and these angles are the same. So we can always take it to tangent by dividing everything by cos x. So if I divide everything, I am going to remain with tan x is equal to 3 over 2. So how did I get to tan x? I divided everything by cos x. Remember, sin x over cos x is the same as tan x. And then transposed 3, and then I divided by negative 2, and then I got tan x is equal to 3 over 2. Now, remember, for sine, we have 2 solutions. So here we are going to have x is equal to the arc sine of minus 1 over 2. It is negative 30 plus k multiplied by 360, where k is an element of all integers. Remember, if you want to make this positive and you are dealing with sine, you can always add 360. And then you'll say, or x is equal to 180 minus into minus 30. It will be 210 plus k multiplied by 360, where k is an element of all integers. And then with tan, so we are going to have x is equal to, and then what is arctan of 3/2? It is the same as 56,31, and then plus k multiplied by 180, where k is an element of all integers. And then we are done with this general solution. So let's move to the last one. Last one, I said that they are 11, but there is a bonus, which is number 12. I will quickly go through it, and then I will end this video. So number 12, we are given sine x minus 30 is equal to cos 2x. Now, with this one, you might be tempted to take this, to use cofunctions here. You cannot change this cos to sine or this sine to cos because of these two here. So here we need to expand. So if we expand this, this is a compound of sine, so it is sine x multiplied by cos 30 minus cos x multiplied by sine 30 is equal to 2 cos x. Now, I change these special angles. So cos 30 is √3/2 sine x minus sine 30 is 1/2 cos x. This is equal to 2 cos x. And then group the like terms. So these and that are like terms. So I will transpose 1/2 cos x. So here I will remain with √3/2 sine x is equal to 2 cos x plus 1/2 cos x. It will be 5/2 cos x. And then divide on both sides, or multiply on both sides by 2. So we are going to have √3 sine x is equal to 5 cos x. And then you will then notice again we have sine and cos, and these angles here are the same, so we can always take it to tangent. We can divide on both sides again. We divide by √3 cos x. Even here we divide by √3 cos x. So this and that will divide each other, and then √3 and √3 will also divide, and then we have an identity. Remember, sine x over cos x is the same as tan x. So we have tan x is equal to 5 over square root of 3. Now we can find the solution. So this is the solution for tan. So x is equal to, now what is arctan of 5/√3? A calculator will give us 70,89 if I'm not mistaken. So this will be 70,89, and then plus k multiplied by 180, where k is an element of all integers.